transmission distribution, today's class. We are in still module 1, introduction to power systems, where we are doing it. Class 1, structure of power system, components of power system over, elements of power system done. Next, effect of high voltage we discussed. Next, we discussed advantages and disadvantages of high voltage transmission lines. Next, we have discussed the overhead transmission lines. In that, we have discussed different types of conductor materials and conductors, properties of conductors, the characteristics, what it should have, and also we discussed about bundled conductors. And next, we went to sagging overhead lines to discuss in class 5. We discussed sagging overhead lines when supports are at equal. See, supports are at equal levels. How calculation can be done, we did it. Now we are moving on to the next part, that is sagging overhead lines, but when supports are at unequal levels. See, when supports are at unequal levels, the diagram shown here, you have to look at. We know that in many situations, practically it is not possible to have the supports at the same level. It is necessary to use the supports at the different levels in the areas, including small hills, rivers, uneven roads, etc. This figure shows an overhead line supported at the supports A and B, which are at the unequal levels. Here, L is span length, H is actually the difference in the levels, T is tension in the conductor, x1, small x1 is the distance of 0.20 from the support A, x2, distance of 0.20 from the support B, W, weight per unit length of the conductor. Applying the results derived in the earlier section, we can also write the sag S1. You can see here from the point A till the lowest point of the conductor. You consider the half span, that is which is horizontal distance is x, for which the horizontal distance is x1. That we know that it can be written as S1 is equal to the lower sag at lower level is equal to Wx1 square by 2t. This is sag at A. Wx1 square by 2t. You can see it's written here. Then while S2 is Wx2 square by 2t. That is sag at B. The sum of x1 and x2 gives the total span length L. That is called as x1 plus x2. Now, if x1 and x2 are known, then sags S1 and S2 can be obtained using these equations. So, subtracting the equations here from the first equation with the second equation, we are getting S2, we are doing S2 minus S1. You can see the result here. I have written W by 2t into x2 minus x1 into L, but it can be seen that the distance H, which is the difference in the levels, is also the difference between the two sags, S1 and S2. Okay, so S2 minus S1 is equal to H. You can call like that also. Substituting this in the equation, S2 minus S1, we get actually H is equal to, small h is equal to WL by 2t into x2 minus x1, where x2 minus x1 is equal to 2th by WL. Solving these equations, you can land up for x1 and x2 separately. Here you can see what is x1 is given by x1 is equal to L by 2 minus TH by WL. x2 is equal to L by 2 plus TH by WL. Once the values of x1 and x2 are known, the sags S1 and S2 can be determined. This is actually you can see the sag at unequal supports. Okay, this is the equation. You can see the diagram here. When supports are at unequal levels, how do you determine the sag? You just Look at the diagram properly. There are two sags. One is sag at lower support and sag at higher support. Sag at higher support is called S2. Sag at lower support is called S1. Substituting that, we got the formulas S1 and S2. After that relation, we got this. So this is about today's class, supports at unequal levels.